Degassing and inclusion removal. Only hydrogen gas dissolves in molten aluminum. Every 200-degree increase in metal temperature doubles the amount of hydrogen that melt can hold. We bubble nitrogen gas through the melt to remove the hydrogen gas from the liquid aluminum. Every 200-degree increase in melt temperature requires 4 times the amount of nitrogen to remove it. The secret of good degassing performance is to produce small bubbles. Proper degassing techniques can also be an effective way to remove inclusions and oxides suspended in the melt. Aluminum is extremely reactive. When molten aluminum metal comes in contact with moist air, the water vapor decomposes and releases hydrogen, which dissolves in the melt. As mentioned in a previous video, the amount of dissolved hydrogen gas in the melt has a big effect on porosity and shrinkage. We, as a quality foundry, carefully control dissolved hydrogen gas levels in the melt. Why do we concern ourselves with hydrogen gas? Aluminum readily holds hydrogen in solution as long as the bath is molten. As the liquid metal solidifies in the mold after pouring, it is unable to hold hydrogen and attempts to rid itself of it. This occurs in the semi-solid state. In trying to rid itself for hydrogen, it leaves voids, or porosity, that can cause deterioration of the final casting properties like poor surface finish, voids that appear after machining, voids in bored or tapped holes, and weaker casting. Inclusions are objects floating around in the melt that have a harmful effect on casting quality. Less inclusions, the better. In our process, there are 3 main sources of inclusions: oxide, pieces of the crucible, and iron. Oxides are formed when the aluminum alloy comes in contact with air. Pieces of crucible usually show up near the end of the crucible's life. Iron comes from not properly coated label or a broken thermocouple tube. The good news is that inclusions have an affinity for small nitrogen bubbles floating to the surface in the degassing process. Large bubbles take about 3 seconds to rise to the surface, while small bubbles take about 10 seconds. The longer a bubble is in the melt, the more opportunity the bubble has to contact to an inclusion. Even a glancing contact connects the inclusion to the bubble as it rises to the surface. The bad news is, when the nitrogen bubble reaches the surface and goes into the atmosphere, the released inclusion does not float and they start to settle back into the... By putting a small amount of cover flux on the top of the melt while degassing, this flux captures the inclusions and holds it. We can then skim the combination of ridding the melt of the inclusions. Gas removal, the process. Rotary degassing with small nitrogen bubbles is the most effective way to remove the dissolved hydrogen gas. Small bubbles rise slowly in the melt, giving them more time to come in contact with the hydrogen gas. Strontium modified alloys, which we use, are easier to degas. There are steps that need to be followed when degassing. Step 1, skim the surface of the melt. Step 2, apply a small amount of cover flux, about 1/16 of an inch worth. Step 3, preheat the device. The reason for this is the carbon tube and rotor can absorb water vapor that need to be driven off before inserting into the melt. The tubes and rotors are especially prone to this. This might take some time if cold. Step 4, move the head into the melt slowly. Never insert or remove the head if it is rotating. Step 5, the best location of the head is at least 4 inches off center of the melt. Setting the head off center enough to still get even a 30-pound ladle is acceptable. If the head is centered in the melt, a vortex is created. This vortex, besides stirring the melt in a circle, which in of itself is not bad, does cause a rolling motion from the top of the melt to the bottom. This pulls oxides on the surface into the melt. Step 6. Once the unit is in the melt, turn on the rotation. Never exceed 300 RPMs and in general, slower is better. Step 7. Adjust the gas flow so you see small bubbles. The surface should be relatively quiet. Small bubbles will seem to dance just under the melt surface. Bubbles should be seen along the complete top. Step 8. After an appropriate amount of time, or when the test says, so skim off the top of the melt and turn off the rotor. Step 9. Raise the unit and then turn the nitrogen gas off. Step 10. Safely store the unit and skim the melt again. Degassing a furnace. Like we said previously, step 1, you always skim the surface. You never want to skim it too hard. You just want to gradually just pull it off to the side. Take the top layer off. Always drain your excess metal out. Doing this process, you'll usually get 3 to 4 skims out of it before you let your cover flux down. Now we're going to apply the cover flux. Distribute it in an even fashion along the surface. Close your lid. Come over to your degassing unit. Turn your nitrogen gas on. Remember to always keep that back. That way you can get a 30-pound ladle in. As well as also remember, brand new gas tube and rotor, you always want to let the moisture in the water dissipate out of it. You bring it down gently and you let it preheat for a couple of seconds. Then you slowly enter your degassing shaft and rotor into the melt. Next, you hook the air to start your rotation. There's the beginning process of your degassing. Okay. Now when you pour it, how long do you want to leave it in there until we do it then? We'll do it now? Okay. Now, what we are going to do is we're going to go ahead and take a gas sample. That'll let us know what we've taken out of here. Always unhook your air to your rotary stop. Raise your degassing unit up out of the melt. And let's stand. Go to your nitrogen and turn it off. Always before you take a gas sample, you have to make sure you clean the surface of any rid. That way you get a proper reading. All right. Just do your dip. When you do your gas, you always want to gently roll back, let the ladle fill up, and then you'll always take it to your gas station. Go ahead. In general, this process takes about 5 minutes. At this time, the caster can keep on pouring, and the day goes on. Okay, the test came back. Our gas level is low. It's at what we need. We guarantee we'll have good parts because of that, providing everything else looks good with the surface finish. Don't worry about it. Raise your degas machine up. And remember safety first. Please be careful and make sure nobody's around you when you move this, because it does have hot liquid metal on it. Now we come back and we skim all the inclusions off the melt, as well as scraping the sides of your crucible. That way you ensure you get everything out of the melt. As I said before, drain the excess metal out of your skimmer. And that is the proper way to degas a pot.